When we solve a problem where we have variables on both sides of the equal sign, our goal ultimately is to figure out what 1x is worth. So we're always going to start by trying to get letters on the left side, numbers on the right side. Doesn't matter whether you start with x's, dealing with the x's or the numbers first. I tend to start by getting only letters on the left side and only numbers on the right side first. So I'm going to start by looking here, and I see I have 5x on the left side, but I also have a plus 36. I only want to have letter terms over here, so I'm going to subtract 36 from both sides of the equal sign. I'm left with 5x equals 9 minus 36 is negative 27, and minus 4x comes down. So all the leftovers come straight down. Now, yay, I've only got letters on the left side, but when I look over here, I don't only have numbers on the right side. I've got this minus 4x. To get rid of minus 4x, I'm going to add 4x to both sides, which makes them go away here, and I have 9x equals negative 27. Okay, so I divide both sides by 9, and I get x equals negative 3. Now, how do I know if I'm right? Well, there's two ways I can tell. The first thing I can do is I can take my x that I've got in here, negative 3, and I can substitute it back into this problem. So 5 times negative 3 plus 36 should equal 9 minus 4 times negative 3. Okay, well, 5 times negative 3 is negative 15, plus 36 is 21. Well, negative 4 times negative 3 is negative 12. Well, I'm sorry, positive 12. 9 plus 12 is 21. They are equal, so I know that it works. The other thing I can do is I can look at my calculator. So I can take this original equation. I'll put, whoopsie, I will put the left side of my equation, so 5x plus 36 in y1, and I'll put the right side, 9 minus 4x in y2, and hit second table. And what I should see there is I thought my answer was negative 3. So I'm going to scroll to negative 3, and if you notice, everything in that row is equal. I have negative 3, 21, 21. So I know that they're equal when my x is negative 3. So in two ways, I've now confirmed that x equals negative 3. So here's another example. This one, instead of just combining like terms, or there wasn't even any combining like terms on the last one, now I've got all this stuff going on. So as always, my first step is always to distribute. So I'm going to take this 3, and I'm going to distribute it to everything inside the parentheses. I don't distribute it to the 2 because the 2 is not inside the parentheses. 3 times 2 is 6m. 3 times negative 1 is minus 3. Now the plus 2 comes down because I didn't do anything to it. Now I'm going to distribute this 4. 4 times negative 3 is negative 12. 4 times positive 2 is, oopsie, sorry, those were m's, is positive 8. Okay. Again, I almost forgot it. 12, that's m, so I got to make sure that I bring the m down with it. Now I'm going to look for things to combine. Over here, I pretty clearly see I have 6m. There's nothing to combine with it, but this negative 3 plus 2, I do have to combine those. Negative 3 plus 2 is minus 1. And there's nothing to combine over here because those are both different kinds of terms. Now I'm at the same point I was on the last problem. I'm just going to start to solve. I want letters over here, numbers over here. So I'm going to add 1 to both sides so that all I have on the left side are letters. Now I've got letters over here and I only want numbers, so I'm going to add 12 to both sides, and I get 18m equals 9. Now a lot of kids in my classes have said, oh, it's 2. No. I always, whatever's in front of the m is what I divide by. So this reduces to 1/2, so m equals 1/2, or 0.5. Now, if I check this one using my calculator, I'm going to do the same thing that I just did. Whoopsie. So I'm going to go 3 parentheses, literally exactly what I see. Now, instead of m, I'm going to put x's. So 3 parentheses 2x minus 1 plus 2. For y2, I'm going to put what's on the right side here, 4 parentheses, negative 3x plus 2, and then I look at my table. Now, I think the answer is 0.5, but notice my table doesn't have 0.5. Now, if you're using the TI-84 or later, you can just hit the plus key, and that'll take you into your table settings. But you may not be using that one. You may be using one of these older ones. And if you are, the way you get to that menu is you hit second window. Now, right now my table start is at -5. I'm not really concerned about that, but if I was looking for an answer like 35, I might want to change that so that it was bigger. But what's happening now is my table is changing by 1 instead of half. So I want to make it change by 0.5 so that I can see half unit increments. Now when I go back into the table, I can see my x's are going up by half. So when I arrow to, whoopsie, I'm going to scroll and scroll and scroll. When I scroll to 0.5, I see 2 and 2, which means that I have solved this correctly. So I know that this answer is correct. Now the last example I'm going to do is kind of crazy looking. This is one where I have fractions, and I don't know about y'all, but I hate fractions. They are scary and weird looking, and I don't want to deal with them. So the way we're going to solve this problem, if these were both fractions that were non-terminating, I would just write this as 0.25x, but this is 2/3, and I can't write 2/3 as a simple non-terminating fraction without having to round. That's not going to give me the precise answer I'm looking for. So I have to use these as they are. The way we're going to deal with this fraction situation is we're going to find the common denominator of 3 and 4, and that common denominator is 12. And then we're going to multiply everything by it. So we're going to distribute a 12 to everything in this equation. So when I multiply fractions, yes, I could do 12 over 1 times 2 over 3, and that's 24 over 3, which works out to 8. That looks like, that's great, but I don't want to have to write that much. So when we see a fraction like this, we're going to multiply by the top number, divide by the bottom number. 12 times 2 is 24. 24 divided by 3 is 8x. 12 times -7 is negative 84. Yeah. Okay, equals 12 times 1 is 12, divided by 4 is 3x. 12 times 3 is positive 36. Okay, so 8x minus 84 equals 3x plus 36. This is a lot more reasonable and easier to work with. So I'm going to add 84 to both sides because, again, I want letters over here, numbers over here. Okay, 8x equals 3x plus 120. Now I'm going to subtract 3x from both sides because I only want numbers over here. I get 5x equals 120. I'm going to divide both sides by 5. I get x equals 24. I happen to know that that's the correct answer, but if you're not sure, you can check it in your calculator or by substitution.